Hello students, welcome to the next lecture on the CSIR NET and the GATE mathematics. Today I will explain you how you can find or how you can solve the PY questions or concept related to the Gram-Schmidt process. I will cover all those questions from the 2004 to 2025. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel. Now, as we discuss in our theory lecture, what is the principle of the Gram-Schmidt process? If you have the set of the vectors v1, v2 and vn such that each of the vi's are not orthogonal. They are not orthogonal. What is the meaning of the orthogonal? You can say vi, any of elements, dot product of the vj is non-zero. Or in other word, you can say the inner product of the vi and vj is non-zero for all I which is not equal to j. Then your target is to convert the given set of the vectors to the orthogonal vector, and the principle which we are using to convert the non-orthogonal vectors to the orthogonal vectors is the Gram-Schmidt process. Fine. So the major target of the Gram-Schmidt process is to convert the non-orthogonal vectors to the orthogonal vectors. And we all know, once we know the orthogonal vector, we can easily convert it into the orthonormal vectors. How you can convert it? That's a very easy. I hope you have already watched my previous lectures, PY questions on the orthonormals, as well as the theory lectures on the orthogonal and the orthonormal vectors. You can see the Gram-Schmidt process examples all are available in this playlist, linear algebra. Now, as I mentioned you, these vi's are my not orthogonal. Then how you can convert it into the orthogonal vectors? By using the Gram-Schmidt process. Fine. And how you can convert the orthogonal to the orthonormals? If you have the orthogonal vectors v1, v2 and vn, you can easily convert it into the orthonormal vectors by dividing the norms of the each vector. v1 divided by the norm of v1, v2 and so on. Another concept is whenever you want to apply the Gram-Schmidt process, the first thing is whatever the vectors you have, let's say a1, a2, ak, all are Li. It must be Li. Fine. For example, if you have say R3, then definitely you have the three vectors v1, v2 and v3. Fine. Out of these three vectors, let us assume the two vectors v1 and v2 are Li only. Fine. Are the Li only. So that means v1 and v2 are Li only. Then you can extend it. This Li vectors to the basis of the R cube. How you can extend it the basis? Because we all know what is the meaning of the basis. We have to find the Li's. So अगर आपके पास दो vectors Li हैं सिर्फ out of the v1, v2 and v3, you can extend it the given vector of the Li's to the basis of R cube by using the Gram-Schmidt process. Fine. But make sure before applying the Gram-Schmidt process, you have to identify the linearly independent vectors. And once you can identify the linearly independent vector, then we can convert it the given linear independent vectors to the orthogonal vectors. I call as a E1, E2, Ek. Such that we have to formulate the relation between, what is the relation between the given AIs and the obtained EI. That is, you can say the span of the AI vectors and the span of the orthogonal vector must be same. Then only you can say the Gram-Schmidt process is applicable. The most important thing is the vectors on which you want to apply the Gram-Schmidt process is linearly independent. How you can construct, the question arises is how we can construct the orthogonal set or orthogonal vector. The only concept which we are using in the Gram-Schmidt process is projection. What is the meaning of the projection? If I say the given vector is my u, another vector is, say, let's say this vector is my v, then you can find the projection, perpendicular projection. Let's say this vector is my b, this is o, and this is my m. Then you can say the bm is perpendicular on the, this vector is, say, oa. Fine. And the om is called as projection. Fine. So you can say the projection of the vector v on u, and you can define as inner product of the projection of the v on u divided by projection. So this is the formula of the projection of the v on u. Fine. Projection of the v on the vector u is v on u divided by u comma u. And based on these projections, we can define these are my orthogonal vectors. u1 uk are my orthogonal vectors. लेकिन आपको ये रिमेंबर रखने की जरूरत नहीं है. I will tell you the shortcut tricks. How you can apply the Gram-Schmidt process in your examinations. And once we can know the orthogonal vectors, then we can easily convert it into the orthonormal. Fine. For more detail, you must watch about my previous lectures, PYQ of the orthonormal vectors. You must watch it and you can learn the concept very easily. I hope you can like and comment on this video as well. Chaliye, let's start with the first question, which is related to the GATE 2005. Consider the real inner product space with the norm is defined as 0 to 1 fx and gx. Capital M is the span. So once is a span, that means you can say the Li. Then the projection, you can see the projection of x square on M. What is the value of the M is? It's a span of the, so what is the, by the definition of the projection, you can say it's a x square comma 1, projection of the x square on 1 divided by 1 comma 1 into 1. Now by using the definition of the inner product, I can write as integration from 0 to 1 x square into 1 divided by integration from 0 to 1 of 1. The numerator integration is 1 over 3, denominator is 1. Answer is my 1 over 3 is the correct answer of the problem. So C is my right answer of the problem. Again, it's a GATE 2010. Let X is the inner product, which have defined the inner product. Let capital X naught is the collection of all those, that is 0 to 1 t square, x comma t is my 0. So if you write this in terms of the inner product, you can see, if you look at that, this number is my t square, x of t is my 0. अगर किसी का डॉट inner product 0 है, what does the meaning of that? That means t square and x of t are orthogonal. Fine. These are my orthogonal vectors. Then you can find the, let y is equal to t cube. Then your target is to find the best approximation. ये statement में कहा ना आपको. Now whenever your target is to find the best approximation, that means your target is to find the projection. So now look at that. Your target is to find the projection of y. What is my y? Y is my t cube. Projection of that t cube on t square. So what is the definition? It is t cube, projection of the t cube on the t square divided by t square into, fine. Now we can apply the definition of the inner product. It is 0 to 1. It's a complex conjugate, but t square is my real. Fine. So the complex conjugate is same. It's a t raised to power 5 divided by 0 to 1 t raised to power 4 into t square. The numerator is 1 by 6, denominator is 1 by 5. So the answer will be 5 over 6 t square is the right answer of the problem. Second, that is a B is the right answer of the problem. Students, I hope you can like and comment on the video as well. अगर आप मेरे चैनल पे नए हो, you can subscribe my YouTube channel as well. Okay, now look at the second one. Next one is, apply the Gram-Schmidt process. I will tell you the shortcut tricks. आप second count करिए, you will get the answer in a 15 second. सबसे पहले जो आपको given vectors है, you can write it. U and V. Fine. 1, 1, minus 1. Is it okay? First of all, check whether they are linearly independent or not, because before applying the Gram-Schmidt process, you need to check whether they are Li or not, and clearly say they are Li, because you can never make 1 from the minus of 1. Fine, they are Li. अब आप एक चीज को ध्यान से देखिए, फर्स्ट एंड सेकेंड आर सेम, दिस आर माई सेम, फाइन, सेकेंड आर सेम, दोनों सेम है. तो लुक एट द ऑप्शंस जिसमें फर्स्ट एंड सेकंड कंपोनेंट सेम नहीं है, उसको डिस्कार्ड कर दीजिए. यू कैन डिस्कार्ड द ऑप्शन फ्रॉम द इन विच फर्स्ट एंड सेकंड आर नॉट सेम. लुक एट दैट, फर्स्ट एंड सेकंड आर नॉट सेम, तो बी ऑप्शन कैंसल. फर्स्ट एंड सेकंड आर नॉट सेम, this option is also cancelled. Is it okay? Now, how you can, out of the A and C, how you can discard the others? Look at that, the vector is 1, 1 and 1. Forget about the denominator. Forget about the denominator. Fine. Forget about the denominator. अब आप इसका रूट निकालिए. 1 square plus 1 square plus 1 square, that is my root 3. तो क्या ये नीचे वही लिखा हुआ है? Yes. Similarly, you can check for the second. It's a 4 plus 4 plus 16. Is it equal to 3? Is it equal to 3? No. This option is also cancelled. Look at this option. Again 1 plus 1 plus 1, that is the root 3. And look at that, 1 plus 1 plus 4, that is 6. Yes, it's my correct answer. So C option is the right answer of the problem. तो देखिए मैंने सॉल्व, सिर्फ मैंने स्टेटमेंट लिखी है, and then you can get the answer in a reasonable time. I hope your reaction will be changed from oof to wow at the end of this video. Once you can watch the complete video, definitely your reaction will change from oof to wow. This is the first method how you can discard the options. Fine. I will tell you the another way. Fine. I will tell you another way also. First of all, is a Gram-Schmidt process. जो भी फर्स्ट वेक्टर है, you can divide it by its length. 1 square plus 1 square plus 1 square. The first vector must be 1 by root 3, 1 by root 3, 1 by root 3. लेकिन ये आपका सेकेंड वाला ऑप्शन कट गया. फर्स्ट, सेकेंड एंड थर्ड आर सेम. फाइन. नाउ हाउ यू कैन फाइंड द सेकेंड वेक्टर? पहले सेकेंड वेक्टर को लिख लीजिए. 1, 1, minus 1. What is the inner product? This is the R cube. Inner product of the R cube is a standard inner product, that is a dot product, xi y, that is you can say the dot product. Fine. Minus थोड़ा दूर करके फर्स्ट वेक्टर को लिख लीजिए 1, 1 and 1. Clear? Now find the dot product of these given vectors. Find the dot product of these given vector. It's a 1 plus 1 minus 1. It's a 1 divided by the length. Length means you can say 1 square, 1 square, 1 square. It is my 3. Now if you solve them, you can see 1 minus 2 over 3. Then it is 1 minus again 2 over 3. Then it is minus 4 over 3. इसका मतलब ये नहीं है कि ये करेक्ट हो गया आपका. फाइन. इसको थोड़ा सिंप्लीफाई करते हैं. You can divide it by 2 by 3. 1, 1 minus of 2. क्लियर? अब इसके नीचे क्या होना चाहिए? रूट से डिवाइड करेंगे. 1 plus 1 plus 4 रूट 6. तो यहाँ पे तो रूट 6 का आंसर ही नहीं बना नीचे आपका. सो दैट ऑप्शन इज कैंसल. दिस ऑप्शन इज करेक्ट. अगेन यहाँ पे माइनस ऑफ 1 आया आपका. 2 minus 1 minus 1, लेकिन आपको 1, 1 minus 2 चाहिए. सो द ओनली ऑप्शन लेफ्ट बिहाइंड इज सी इज द राइट आंसर. क्लियर? अब इसी अप्रोच से सारे क्वेश्चन को सॉल्व करेंगे. लुक एट दैट. अगेन there is a span. Fine. So that means your target is to find the orthonormal. You can apply the Gram-Schmidt process. Firstly, we can check whether the given vector S is Li or not. Fine. How you can check? I can write we can check the determinant. 2 minus 1 0 2 1 minus 2 1, and we will see what is the determinant. 1 into plus 4 minus 1, 2 into minus of 2 plus of 1 minus of 2 into plus 1. So that number will be sorry, it's a 4. 4 plus 1. That number is plus 3 minus 0 minus 3, which is 0. Therefore, the given vectors are my LD. But before applying the Gram-Schmidt process, we need the Li vectors. तो आपको because it's a 0, so I can delete the last row. तो पहला वेक्टर आप ले लेते हैं 1 1 1 और सेकंड वेक्टर आप ले लेते हैं 2 minus 1 2. Is it okay? Now you can see the options. सबसे पहले वही रूल चेक कर लेते हैं. You can see the first and the last are same. First and the last are same. Fine. First component and the third component are same. So look at the option जिसका first and third component same नहीं है. B option cancel. Fine. First, third same नहीं है. Option cancel. First option, third option same नहीं है. Cancel. First option same है. Third option, only one of the option is left. A is the right answer of the problem. This is the first method. Fine. Second method is instead of writing as the first and third component, how you can write it? Now, what is the rank of this matrix S is 2, because linear dependent हो गया ना, तो इसका मतलब इसका ग्राम स्मिथ प्रोसेस में only 2 वेक्टर मस्ट बी देयर. लेकिन यहाँ पे आपके कितने हैं? दे आर द 3 वेक्टर्स. दिस ऑप्शन इज कैंसल आउट. फाइन. नाउ लुक एट दैट. फर्स्ट वेक्टर क्या होना चाहिए? इसको इसकी लेंथ से डिवाइड होगा. लेंथ विल बी 1 + 1 + 1 3. सो लुक एट द ऑप्शन जिसमें 1/√3 1/√3 सभी में 1/√3 है. सेकेंड वेक्टर को कैसे लिखेंगे हम? सेकेंड वेक्टर को पहले लिख लेते हैं 2 - 1. फाइन. माइनस ऑफ द फर्स्ट वेक्टर 1 1 1. फाइंड द डॉट प्रोडक्ट because it's a standard inner product of the R cube. So find the dot product. 2 - 1 plus 2. That number is 3 divided by the length. What is the length of the previous vector u is 1 + 1 + 1. So ये 1 हो जाएगा. That is a 1 0. Sorry, 1 minus of 2. 1 minus 2 and 1. So you can see यहाँ पे तो 0 1 - 1 है. आपको तो 1 - 2 1 चाहिए. दिस ऑप्शन इज ऑल्सो नॉट करेक्ट. 1 - 2 1. और ये डिवाइड किससे होगा? इसकी लेंथ से 1 + 4 + 1 दैट इज 6. A is the right answer of the problem. Okay, look at this another one. Again it's R4. Now you can see some March 25. That means the inner product is my standard dot product. Fine. V is the subspace. So firstly we will check whether this is Li or not. 1 0 0 1 0 1 0 1 0 0 1 0. Clearly say the rank of the matrix S is my 3, which is not equal to the number of the column vector. So therefore yes, they are Li. Fine. अगर Li है तो फर्स्ट वेक्टर क्या होगा आपका? 1 0 0 1. फाइन. सेकेंड वेक्टर क्या होगा आपका? 0 1 0 1. थर्ड वेक्टर इज 0 0 1 0. तो इसको लेंथ किससे डिवाइड होगा? इट मस्ट बी √2. इज इट ओके? इट मस्ट बी √2. सो 1/√2 1/√2 1/√2. ये भी सेम है बिकॉज बोथ आर नेगेटिव. सो माइनस कैंसिल हो जाएगा. फर्स्ट ऑप्शन आर सेम. फाइन. यहां देखिए थर्ड में बोथ आर सेम. फाइन. तो इसका थर्ड कंपोनेंट सेम होना चाहिए. फाइन. ऑल आर माई सेम. क्लियर. नाउ हाउ यू कैन फाइंड इट? माइनस फर्स्ट प्रीवियस वेक्टर लिख लेते हैं 0 0 1. इन दोनों की डॉट प्रोडक्ट करिए. डॉट प्रोडक्ट विल बी 1 डिवाइडेड बाय द लेंथ 1 + 1 is 2. तो ये कितना आंसर हो गया? 0 माइनस इस -½ 1 - 0 1 0 - 0 is 0 1 - ½ is ½. इसको 2 से मल्टीप्लाई कर लेते हैं. -1 2 0 1. फाइन. अब आप चेक करते हैं. इसको डिवाइड किससे होगा? ये √4 + 1 + 1 √6. सो -1 इसे √2/√3. यस, इसको मैं √2/√3 लिख सकता हूं. यस, इससे करेक्ट. हमें नॉट ढूंढना है. नेगेटिव पॉजिटिव. यस, इससे फाइन. ये गलत हो गया. देखिए ये नेगेटिव आ गया ना. हमें क्या चाहिए? पॉजिटिव. सो दैट मीन्स दिस इज नॉट द ऑर्थोगोनल वेक्टर एंड इट इज फाइन। अगर आप माइनस से मल्टीप्लाई कर देते हो देन इज 1√2 और ये लास्ट वाला तो सेम ही है। सो सी इज द ओनली राइट आंसर ऑफ द नॉट ऑर्थोनॉर्मल वेक्टर्स। Okay, look at this another one. XKs are the orthonormal set. What is the meaning of the orthonormal set? If I say xi, xj, it will be 0 and norm of the each xk must be 1. It is given to you with a real Hilbert space. किसी x को कोई भी Hilbert space ले सकते हो, आप L2 को भी ले सकते हो, चॉइस आपकी है. Y is the span of xk, where k varies from 1 to n. Let capital N is there. Which of the following is the okay? So you can see xn. क्या मैं इसको ये चीज लिख सकता हूं x, xk डिवाइडेड बाय xk, xk. क्या इसको मैं इस तरह से लिख सकता हूं? यस, बिकॉज the norm of the length is my 1, so denominator 1 हो जाएगा. So what is the meaning of that? This is a projection of, this is the projection of x on xk. Fine. And it is k varies from 1 to n. तो इसका मतलब अगर मैं फर्स्ट वेक्टर निकालूं that is my x1, second vector will be x2 minus projection of the x on x1 डिवाइडेड बाय फाइन, और इसको x मेरा x2 हो गया एंड सोन. सो दैट मीन्स जब ये चीज आपके पास क्या रह गई, दिस इज व्हेन n इज इक्वल टू 1 एंड सोन करोगे तो लास्ट में जाके समेशन हो जाएगा. सो दैट इज माई, दिस इज माई प्रोजेक्शन. फाइन. एंड बाय यूजिंग द ग्राम स्मिथ प्रोसेस u1 and u2 are my orthogonal vectors. Now look at the options. Sn is the projection of the x on xk. What is xk is y. So that is a projection of the x on y is the correct option. Sn is a projection of the x on the orthogonal complement. That's a wrong option. X minus Sn. What is x minus Sn is? X minus Sn is basically my like of un, and un is the orthogonal to the previous value u of n minus 1. So xn is orthogonal to the Sn for all x. Yes, it's also the correct option. And the summation of the xn square is equal to, तो ये नहीं होगा. We can apply the modulus firstly, then by using a Cauchy-Schwarz inequality it must be less than of norm of x square, norm of xk square. Norm of xk square is my 1 by using the orthonormal, so it must be less than or equal to, but not always equal to. That is option is cancel. Otherwise you can put as a one arbitrary example. Let's say n is my 1 and 1 ले लेते हैं. So then it will be x xk which is equal to norm of, तो कोई भी एक x ले लो आप, let's say 1,0 और x के कुछ भी आप ले लेते हैं, let's say 4,3. then what is the inner product of the, so that is my 4. ये आपका 4 हो गया, it's a square. But what is the norm of the x square? 1, which is not same. So right answer are A and C are the correct answer of the problem. Which of the following set is my orthonormal? Fine. Orthonormal बोला है तो क्या प्रॉपर्टी होनी चाहिए? Vi dot Vj, it must be 0. Norm of the each of the Vi must be 1. तो सबसे पहले ये चेक कर लेते हैं, इसका नॉर्म 1 आ रहा है. फाइन. दिस इज ऑल्सो 1. डॉट प्रोडक्ट इज 0. क्लियरली से दैट डॉट प्रोडक्ट इज नॉट ए 0. अगर आप इसका डॉट प्रोडक्ट करोगे इट इज 15/65 प्लस 48/65 which is not 0. First property is not satisfied. You can see the length is not a 1. Is the second property satisfied? 1 plus 1 which is not equal to 1. Third option cancel. Look at the dot product. Minus √3/4 and plus root 3 by 4, which is 0 satisfied. Now we can check the norm. Norm will be 3 by 4 plus 1 by 4, which is 1. Similarly for the second one, 1 by 4 plus 3 by 4, which is 1. Yes, A and D are my right answer of the problem. बच्चों मैं बार बार कह रहा हूं, आप ये PY क्वेश्चन ऑफ ऑर्थोनॉर्मल as well as these 4 lectures, Gram-Schmidt process, examples, and the orthogonal and the orthonormal vectors. These 4 lectures are very, very helpful to all of you for the CSIR net, for the GATE, fine, even for the IIT JAM study as well. Whenever you try to understand the linear algebra, watch these lectures. My playlist is linear algebra. आप इसके अलावा आप ये भी देख सकते हो, इसके नीचे PY क्वेश्चंस भी हैं. Moreover, there is a separate playlist of the CSIR net UGC GATE. Fine, you can watch all these previous PY questions in these lectures. चलिए look at the next one. Consider the inner product space with the inner product F and G. V is the span of T square such that find the H such that 2 of T minus 1 minus H of T, which is less than equal to 2 of T minus 1 minus X of T. Very simple. Firstly, I will tell you the shortcut tricks. Fine. Whenever you can say U minus is U minus A and this is my B. Fine. Clear? And your target is to find the B. Always remember, B is nothing but my projection of U on the given set V. Fine. B is the projection of the U on the given vector space V. तो इस एग्जाम्पल में what is the H? That means H of T is the projection of 2T minus 1 on V. V is my T square. That is the required target. Fine. तो अब आप इसको कैसे निकालोगे? How you can write the projection? That is 2T minus 1 comma T square divided by T square comma T square. Fine. Now you can integrate them over the 0 to 1. So if you multiply them, it's a 2T cube minus T square divided by T raised to power 4 into T square. So the numerator becomes 1 by 4. 2 by 4 means 1 by 2 minus 1 by 3 divided by 1 by 5. 1 over 6 divided by 1 over 5. That is 5 over 6 into T square is the right answer of the problem. Always remember, whenever the first quantity are same, it must be same. Fine. Then H of T is the projection of the 2T minus 1 on the span of the V, span of T square. Chaliye, look at this another one. Find the orthonormal basis of the V. V is a collection of all those M into X transpose. Firstly, we will check what is the rank of the M so that we will know what is the determinant, what is the Li. So we can check about the determinant. Determinant will clearly say the last two rows are same. Fine. So the rank will be 2. So once the rank is 2, that means there are 2 linearly independent vectors. तो जो ऑप्शन इसमें 3 वाले हैं 3 और 3 because there are the 3 vectors. These are cancelled. Your target is on the X transpose. So look at the column. First vector will be 1 0 0. Second vector will be 1 1 1. Is it okay? तो first vector में क्या आएगा? Divided by its length 1. So look at the option 1 0 0. Fine. इसको कैसे करेंगे? Minus previous vector. Fine. Minus of R cube है तो that's a standard inner product. Find the dot product of these two vectors. Find the dot product is a 1 divided by its magnitude. So ये कितना आंसर हो गया? 1 minus 1 0 1 and 1. तो इसे किससे डिवाइड होगा ये, इसकी लेंथ से √2। तो यहाँ पे तो 0 1 1 ही नहीं है, इसे 0 1 1 एंड √2। बी इज द राइट आंसर ऑफ द प्रॉब्लम। लुक एट द अनदर वन, द एप्लीकेशन ऑफ द ग्राम स्मिथ प्रोसेस। तो सबसे पहले चेक कर लेते हैं क्या ये LI है, 110 100 111। सो चेक द डिटर्मिनेंट। 1 के साथ करेंगे 0 -0, फाइन। -1 के साथ करेंगे 1 -0, 0 के साथ 0, दैट इज -1 विच इज नॉन जीरो, दैट इज LI, फाइन। तो फर्स्ट वेक्टर लिख लेते हैं 1 1 0, सेकेंड वेक्टर इज 1 0 0, थर्ड वेक्टर इज 1 1 1। क्लियर। द फर्स्ट वेक्टर क्या आएगा, इसको किससे डिवाइड करना आपको, इसकी लेंथ से, दैट इज √2। तो किस में आपका ये देखो सी ऑप्शन में √2 से डिवाइड नहीं है, इट्स 110 110 110 डिवाइडेड बाय √2, फाइन। क्लियर। अब आप देखो इसमें थर्ड कंपोनेंट एंड थर्ड कंपोनेंट सेम है, तो इसका भी थर्ड कंपोनेंट 0 ही होना चाहिए। क्लियर। अब आप कैसे निकालेंगे, माइनस ये प्रीवियस वेक्टर लिख लेते हैं। क्लियर। फाइंड द डॉट प्रोडक्ट, बिकॉज आप RQ पे हो, इसका डॉट प्रोडक्ट कितना हो गया 1 डिवाइडेड बाय द लेंथ, लेंथ इज माई 2। तो ये कितना आंसर हो गया, 1 - ½ इज हाफ, -½ 0। तो इसको माइनस ऑफ, इसको 2 से डिवाइड कर लेते हैं, इससे 1 -1 0, फाइन। तो पहले चेक कर लेते हैं 1 -1 0 1 -1 0, यहाँ 1 -1 0 नहीं है, तो दिस ऑप्शन इज कैंसल। तो ये किससे डिवाइड होगा, इसका √2 के साथ। अब थर्ड वेक्टर, बिकॉज अब आपके पास दो वेक्टर हो गए, एक प्रीवियस वेक्टर इज 1 1 0 और एक जो आपने अभी निकाला है 1 -1 0, फाइन। अब इसको भी इसी तरह से करेंगे, फाइंड द डॉट प्रोडक्ट ऑफ द थर्ड वेक्टर विद द फर्स्ट वेक्टर, 2 divided by the length. Find the dot product of the third vector with the second one. So 1 - 1 0 divided by 2. तो ये कितना आंसर हो जाएगा, 0 0 1। तो आप देखो 0 0 1 सेटिस्फाइड, लेकिन यहाँ 1 1 1 है विच इज नॉट सेटिस्फाइड। द राइट आंसर इज डी इज माई करेक्ट आंसर। इसमें आपको किससे डिवाइड करना होगा, √1 से ना, तो दैट इज डी इज द राइट आंसर ऑफ द प्रॉब्लम। ओके, फाइंड दी ऑर्थोनॉर्मल बेसिस अगेन ऑफ द रेंज। तो पहले रेंज को चेक कर लेते हैं, x y z, x y z, x y z। तो पहले LI को चेक करते हैं, सो दैट विल बी 1 -0 0 एंड -1 विल बी 1 -0, so that will be 1 - 1 is 0, that means they are LD, फाइन। तो अगर LD है तो किसी एक रो को डिलीट कर दिया, सॉरी हमने कॉलम वाइज लिखा था ना इसकी वैल्यू, वी हैव राइट इन द कॉलम वाइज, तो एक कॉलम को डिलीट कर दो। तो पहला वेक्टर क्या हो गया आपका 1 1 0 एंड सेकेंड वेक्टर इज 0 1 1। अब इसका LD है तो इसका मतलब 2 LI वेक्टर्स हैं, ऑप्शन में जहां पे 3 वेक्टर्स लिखे होंगे कैंसिल कर दो, इस सभी में 2 ही हैं। तो फर्स्ट वाले में किससे डिवाइड होगा, ये 2 से। तो लुक एट दैट ऑप्शन, ये नेगेटिव आ गया। देखिए आपको क्या चाहिए 1 and 1, लेकिन यहां तो 1 and -1 हुआ, फाइन। बाकी 3 ऑप्शन सही है। माइनस प्रीवियस वैल्यू लिखिए 1 1 0, डॉट प्रोडक्ट करो इसका, डॉट प्रोडक्ट इज 1 डिवाइडेड बाय द लेंथ, लेंथ इज माई 2। तो ये कितना आंसर हो गया, -½ 1 -½ एंड 1। इसको 2 से डिवाइड कर देते हैं, या 2 से मल्टीप्लाई कर लेते हैं, -1 1 एंड 2, फाइन। ये किससे डिवाइड होगा, इसका 4 + 1 + 1 √6। तो सबसे पहले -1 1 एंड 2 चाहिए, लेकिन यहां तो सारे 1 1 एंड 1 है, ये ऑप्शन कैंसिल हो गया। 1 -1 -2 1 -1 -2, नीचे √6 है, करेक्ट हो गया। ऑल आर माई 1 1 एंड 1, लेकिन मेरे को 1 1 एंड 2 चाहिए, सो दैट ऑप्शन इज कैंसल। सी इज द राइट आंसर ऑफ द प्रॉब्लम। Similar kind of the examples we already discussed in the theory lecture of the ortho of the Gram-Schmidt process. चलिए look at the next one. Now it's a June 2023. Let V the inner product space such that VI's are orthogonal What is the meaning of the orthogonal is V1 inner product of the V1 and V2 is 0. Inner product of the V1 and V3 is 0. Inner product of V2 and V3 is 0. Fine, they are only the orthogonal. Orthonormal है, इसकी कोई गारंटी नहीं है अभी. Then which of the following set can be extended to the basis? बेसिस में कैसे जा सकते हो? अगर आपने ये प्रूफ कर दिया कि ये Li है तो आप इसको एक्सटेंड कर सकते हो बाय यूजिंग द ग्राम स्मिथ प्रोसेस. फाइन, तो सबसे पहले इस वेक्टर को चेक करना वेदर दे आर Li और नॉट. तो इसके लिए चेक कर लेते हैं इसकी मैट्रिक्स V1 V2 V3 कॉलम. आप रो में भी लिख सकते हो, चॉइस आपकी है. V1 V2 V3 V1 V2 V3. तो कितना आएगा इसका डिटर्मिनेंट? 3 minus 1 which is 2 is a non-zero. Therefore they are Li, and once they are vectors are Li, you can extend them to the basis of the V by using the Gram-Schmidt process. So which of the following statements are true? Yes, first option is the correct option. Look at the second one. Can be extended to the orthogonal. Fine. तो सबसे पहले इसकी मैट्रिक्स बना लेते हैं. 1 1 2 0 1 1 and 0 1 3. Whether they are orthogonal or not. Fine. Whether they are orthogonal or not. How you can check? We can find the dot product of the row column wise. What is the dot product? Dot product is 3, which is not 0. Hence they are not orthogonal. Fine. तो ये ऑर्थोगोनल ही नहीं है तो एक्सटेंडेड ऑर्थोनॉर्मल में नहीं होगा. Fine. Always remember students, if you prove that the set of the vector is orthogonal, that implies they are Li, but converse is not true. Fine. Converse, like same example, you can see they are Li, but they are not orthogonal. Look at the third set. The given set can be extended to the basis. So again we can write the vectors as a matrix 1 1 2 0 1 1 2 1 3. So find the determinant. 3 minus 1 is 2. 0 will be 0 plus 1 minus 2. So that is my 0. Therefore the given set of the vectors are LD. So once they are LD, it can never extend it to the basis. Look at the last one. Fourth option. 1 1 2 2 1 1 2 1 3. So find its determinant. 3 minus 1 minus of 2 3 minus 2 plus of 2 1 minus 2. So that number is 2. Is a minus of 2. It's a minus of 2, which is non-zero. That means the given set of the vectors are Li. So once they are Li, yes, you can extend them by using the Gram-Schmidt process. A and D are my right answer of the problem. Okay, look at this another one. Let W is the subspace of the R4, the square of the distance to the subspace. Always remember students, whenever you have to find the distance of some point to the subspace, fine, always apply the Gram-Schmidt process. Clear? So how you can apply that? It's a very simple. Firstly I will tell you the graphically. जो ये दो वेक्टर्स हैं, फाइन, दिस इज अ लेंथ, इसको छोड़ दीजिए. फाइन, दिस इज ऑर्थोगोनल. इस वेक्टर को यहाँ पे डिफाइन कर दो आप 0 0 1 1 और दूसरे वेक्टर को यहाँ पे भी 1 minus 1 0 0. Fine, I call this number is my U2, this number is my U1. Fine, सबस्पेस डिफाइन कर लेते हैं. लेट्स से दिस इज माय A. तो A के कोऑर्डिनेट्स क्या हो जाएंगे? हाउ यू कैन डिफाइन द सबस्पेस? अल्फा 1 U1, अल्फा 2 U2. तो क्या होगा? अल्फा 1 into U1 is alpha 2 is U2, that is alpha 2 minus alpha 2, alpha 1, alpha 1. These are the coordinates of the A. Now, whatever the point is given to you, this point is my say B. The distance from the origin is 1, 1, 1 and 1. Now, whatever they have asked you, find the distance. Distance means your target is to find AB. This is your required distance. Fine. So that means our target, what is your target? Your target is to find the A. जैसे A मिलेगा, we can apply the distance formula. How you can find the A? For finding the A, our target is to find the value of alpha 1 and alpha 2. Fine. Now what is the property is? Your target is to find the alpha 1 and alpha 2 such that the vector AB is orthogonal to the U1 and the vector AB is orthogonal to the vector U2. इन दो इक्वेशन से हम अल्फा 1 अल्फा 2 निकालेंगे. So firstly, what is the AB? If you look at the diagram, I can write this vector is OB minus AB, OB minus OA. What is the OB? 1 1 1 and vector A, or position vector of the B minus position vector of the A. So that number will be 1 minus alpha 2, 1 plus alpha 2, 1 minus alpha 1, 1 minus alpha 1. Fine. Now find, this is the AB, find the dot product with the U1 because there are 4 standard in a product. So that number will be, if you find the dot product, that number is 2 minus 2 alpha 1 is 0. And find the dot product of with respect to U2, that number will be minus 2 alpha 2 is equal to 0, which implies alpha 2 is my 0, alpha 1 will be 1. So what is the coordinate of the A? A will be 0, 0, 1, 1. Fine. And once you know that coordinates, so can you find the distance? By using the distance formula, 1 minus 0 square, 1 minus 0 square, 1 minus 1, 1 minus 1. That is root 2. And your target is to find the square of the distance. The square of the distance is my 2 is the correct answer. Look at the another one. Consider the R cube with the user inner product. Again, you can see your target is to find the distance on this subspace. So again, this vector is my U1. This vector is my U2. So I can find the coordinate of the A by using alpha 1, U1, alpha 2, U2, which is alpha 1 plus alpha 2 and alpha 2. This is point B. As in the previous diagram, this point is A and your target is to find AB. So what is the AB? Position vector of B minus position vector of A. 1 minus alpha 1, 1 minus alpha 1 minus alpha 2, 1 minus alpha 2. Now the dot product of the AB with respect to U1 is 0. That implies 2 minus 2 alpha 1 minus alpha 2 is equal to 0. Dot product with respect to U2 is 0. Minus alpha 1 minus 2 alpha 2 is equal to 0. Can you find the value of the alpha 1 and alpha 2? I can multiply this vector by 2 and subtract them. 4 minus 2 is 2. 4 minus 1, 3, 0. Fine. Which implies alpha 1 is 2 over 3. I can substitute the value of the alpha 1 in the second equation. 2 minus 2 over 3, which is equal to 2 alpha 2. That implies 6 minus 2 is 4. 4 by 2, that is a 2 by 3. So what are the coordinates of the A? Coordinates of the A is 2 by 3, 4 by 3, 2 over 3. So can you find the distance? So let's see what is the distance. Coordinate of the B is 1 1 1. Coordinate of the A, so that number will be x2 minus x1 whole square, y2 minus y1 whole square, and z2 minus z1 whole square. So 1 over 3 is 9, 1 over 9, 1 over 9. So that will be 1 over root 3. Now your target is to find the 3 into d square. 3 into d square, that is 1 is the right answer of the problem. So you can see that it's a very simple way we can find the Gram-Schmidt process orthogonal way. You can follow my YouTube channel. You can like and comment on this video as well. We will see the next lecture very soon on the PY question of the inner product space. Let me know in the comment box, are you interested to watch this, and your target is changed from the off to wow or not. I hope you can share this video with your friends, like and comment on it. Thanks for the watching. Happy learning always.